if they ask you to find the, let's say, ninth term of the geometric sequence 3, 2, 4 over 3, 8 over 9, what are you going to do? So the first thing that you want to do is to get the easiest, okay? So you can see the first term. The first term, which we call A or A1, it's going to be 3, okay? After that, what you want to see is obviously the common ratio. The common ratio, you know that it's going to be 2 divided by 3, and you prove that because you know that 4 over 3 divided by 2 is the same as 2 over 3. So that is going to be your common ratio. Okay, so what do you know? Using this formula that we have over here, okay, what you know is that you have A sub n is going to be equal to A sub 1, which is 3. Okay, R, what's R? Always put the parentheses, 2 over 3, and then to the power of n minus 1. Are we okay with that? So we have this in general. What sub do you want? You want the ninth. Okay, so you plug the 9 here, and obviously you're going to have that A sub 9 is going to be equal to 3 times 2 over 3 to the power of 8. Okay, and this is going to be your ninth term. That's it. Okay, so let's do the next one. Find a recursive formula for the sequence. What are you going to do? Well, when we were talking about recursive, you need to find the first term. You know that A is equal to A sub 1, okay? You also know another thing. A sub n is equal to R times A sub n minus 1, okay? Okay, so what do you have here? You have that A1 is going to be equal to 3 using the same one, okay, because we know that the first term is 3. And then you know that A sub n is going to be equal to what was R. You know that the R is what? 2 over 3, okay, use the parentheses times what's A sub n minus 1. Well, it's that in general. So this is going to be your recursive formula. Okay, you have two pieces for a recursive formula, the first term and the general term. Okay, so now that we know how to find a formula for a geometric sequence, let's look at how to find the sum of the first n terms. Okay, so obviously we're going to have a sequence, a geometric sequence with the first term A sub 1 and common difference of R, where R is different than 0 and different than 1. Then the sum S sub n of the first n terms of the sequence is going to be the following. You know that if we do it one by one, it's going to be A sub 1 plus, and it's going to be A sub 1 times R plus, it would be A sub 1 R to the power of 2 and so forth, but here I'm running out of space, so I'm going to have A sub 1 up to R to the power of n minus 1, okay? So if I want to condense all the situation, because here you have the dot, 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 right? Be more specific, I have that it's the summation. My index is k, okay? So it's going to be A sub 1, okay? Because that appears in every single term, okay? It starts at 1, it ends at n, okay? So you have that it's going to be R. Since you are using k as your sub-index, k is going to appear here minus 1 because the formula is n minus 1. So you just change instead of n, k, okay? So you know that this, okay, well, you don't know that, but that's going to be the new formula that you have. It's going to be A sub 1 times, and it's going to be, well, let me write a huge parenthesis here, 1 minus R to the power of n, okay? Everything divided by 1 minus R, okay? When obviously R, for R that it's different than 0 and 1, okay? So please remember the one at the top is going to be to the power of n, and the one at the bottom is going to be to the power of R. This is a very important formula, okay, that it will help you to find the sum of the first n terms, okay? So let's look at the example. Find the formula for the sum of the first n terms, okay, of this sequence 3 to the power of n, then use that formula to find the sum of the first 8 terms, okay? So what are you going to do? The first thing that you want to do is you want to find A, or your first term, okay? Remember, this ends, they start, n is going to be starting at 1, 2, 3. Remember, they are integers, okay? So they go up to, let's say, k. Okay, so what are you going to do here? Your first term, or a, okay, sub 1 or a, however you want to call it, is 3. Okay, after that you want to find your common ratio. Your common ratio, following the same from the previous page, you have that it's 3 to the power of n divided by 3 to the power of n minus 1, which you know that clearly it's going to be 3. Okay, because this is as if you have a parenthesis here. Okay, now we're going to use this formula. If we use that formula, what do you have? You have, in general, they want you to find the n. Okay, so we're going to find the general first. S sub n is going to be equal to a1. What's a1? You know that it's 3. Okay, times what? 1 minus r, okay, to the power of n. Are we cool with that? Then you divide this, 1 minus 3, and put everything into a parenthesis, okay? And that's what you have. Now, let's move on to this part, okay? To the second part. Let's say that you want to simplify. Do you want to simplify? Maybe, okay? So if you want to simplify, you know that this is going to be what? This is going to be negative because this is a negative 2, so I would pass negative 3 over 2, okay, which is this one, and then I would put a parenthesis, 1 minus 3 to the power of n, if you want to simplify it, okay? That would be it, okay? Now, for the first 8 terms, what are you going to do? You plug the 8 here and here. So pretty easy. S sub 8 is going to be equal to negative 3 over 2, 1 minus 3 to the power of 8. Okay, if you plug this in your calculator, the calculator will give you 9840, and that's it. Okay, that's pretty much it. Simple. Okay, now for B, to find the sum of the first 15 terms of this sequence, what are you going to do? Same thing. You discover your a sub 1, which is going to be a sub 1. You know that it's going to be 1 over 5, because again, you're going to plug the 1 here, okay? Unless I tell you to plug the 0, you're always going to plug the 1, okay? So then you have what? R is going to be equal to what? Okay, you know that it's going to be equal to 1 over 5 to the power of n divided by 1 over 5 to the power of n minus 1. Okay, this is going to be equal to 1 over 5. Wow, they are the same. Can this happen? Yeah, it can. Okay, so they want the first 15, so they want S sub 15, which is going to be equal to what? It's going to be equal to 1 over 5, parenthesis, 1 minus 1 over 5 to the power of 15, okay, divided by 1 minus 1 over 5, okay? You plug this in the calculator, you have that this is 0.25, and that's it, okay? So don't overcomplicate this, pretty simple, move on, okay? So the next definition that we're going to see is quite important, okay? So an infinite sum of the form like this, like the previous one that we saw, with first term a sub 1 and common ratio r is called an infinite geometric series, okay? And it's denoted by the summation from k equals 1 up to infinity of a sub 1 r k minus 1, okay? So this is what we call in calculus and also pre-calculus series. What is the difference? A series is a partial sum. You have the sum of something. The sequence is just the collection of the numbers. That's a big difference, okay? Now let's move on and analyze more about this super interesting geometric series. This one you're again going to see it in calculus again, but might as well I introduce you to it, okay? This is R, this is nothing more than the common ratio, okay? So the condition is here. If the absolute value of the common ratio is less than 1, we say that the infinite geometric series, this converges, okay? As easy as that. Its sum, it's going to be equal to what? It's going to be equal to the summation from k equals 1 to infinity. As you can see, we have the infinity now instead of the n, of a sub 1 times r to the power of k minus 1, and this is always going to be equal to a sub 1 divided by 1 minus r. Okay, this formula, all my calculus BC students usually memorize this formula because it's that important and it's pretty simple. Okay, so determine whether a geometric series converges or diverges. We need to determine whether this 1 plus 1 over 3 plus 1 over 9 plus ... converges or diverges. If it converges, find its sum. Okay, so first we need to figure out if it converges or not. Okay, so what are you going to do first? The first thing that you need to discover, of course, it's going to be to find the first term. The first term, it's going to be a sub 1, okay? So it's going to be 1, okay? And that's going to be always the first term, okay? The first partial sum, okay? Then what's going to be your common ratio? Your common ratio is nothing more than what we saw before, which in this case it's going to be the second term, which is 1 over 3, divided by the first term, which in this case you need to prove if this is equal to this, which you know that it's true. Okay, so this is going to be 1 over 3. Okay, so the common ratio is 1 over 3. So what do you have? You have that the absolute value of 1 over 3 is indeed less than 1. If it's less than 1, let me show you here. If it's less than 1, what can we conclude? That it converges. Okay. Okay. So what's going to be this sum? When it converges, when something converges, it means that it's finite. Okay, it's going to some number. Okay, it's going to add up to some number. Okay, so what you're going to do here, you know that you want 1 plus 1 over 3 plus 1 over 9 plus up to infinity, right? Okay, so you know that this is going to be equal to what? This is going to be equal to a1, which is going to be 1 in this case, very conveniently, divided by 1 minus 1 over 3. Which you know that this is going to be equal to 1 divided by 2 over 3, which you know that this is going to be 3 over 2. So the sum is, thus, the sum is 3 over 2. Wow, can that happen? Yeah, it can happen. Why? It gets smaller and smaller, okay? So it tends to 0, the numbers, okay? And we're going to cover that next year in calculus, okay? So now we need to show that the repeating decimal 0.88888 equals 8 divided by 9. Wow, this is very interesting, okay? So what can you... I'm going to think about something, okay? So I'm like, okay, so they want me to represent this situation as a fraction. Okay, so if I'm adding, I'm talking about series, I'm talking about partial sums. Okay, so I know that this is the same as 0.8 plus 0.08 plus 0.008 plus 0.008 ... I know that this is true, right? Okay, so what do you know? You have that the common ratio, what's the common ratio? The common ratio is going to be this guy, which is going to be the same as this. That's true. Okay, which I know that this is going to be 0.1, don't you think? Okay, after that you are like, oh wow, then if that's my common ratio, can I assume that my first term is going to be 0.8? Yeah, you can do that. So, what do you know? Can you tell me what's the sum? Okay, that this is equal to this. Okay, so you know that this ... is going to be equal to 0.8 using this formula. Okay, it's going to be 0.8 divided by 1 minus 0.1, which is going to be equal to 0.8 divided by 0.9. And what do you know here? Wow, this is the same as 8 over 9, which is the original, so